Hello everyone and welcome back to this continued research and development video where we are discussing Lee's terrain system and means in which we can go about storing data changes in regards to the vertices that are being manipulated by an artist on the terrain that is being generated. So picking right back up, where do we want to start at? Nelson, you already were hitting me with some stuff off camera and I told you to hang tight until we came back. What's on your mind?
I don't know. I've been thinking about I guess the best way to persist this sort of data, and I have a lot better idea about how this is going to be stored. At least, so far we pretty much just, at least as of now, the data that really needs to be stored is for every patch that has a change in it, we need a block of compressed data that represents the difference between the original height map and the changed height map. Is that fair?
That's how I understand it.
And what I have as code available for me that I've already messed with and have functional is the ability to give you a run length encoded compressed bit string.
Run length?
Yep.
I'm not familiar with that.
It basically looks at a whole bunch of values, and if they're the same number, it counts those. So if let's say okay. And it just basically shrinks it. So what happens is the methods that I wrote, and at some point we'll probably even turn them into R&D videos, is it'll look at the data, it will compress it and look at that compressed version versus the non-compressed version, and then it'll give you a bit stream out of whatever was the smaller of the two. So,
okay.
And then that information can then be handed off to whatever storage mechanism, and then you could save that as whatever you need. As long as you give me that exact same thing back, I can then decode it and put it back into the system.
Have you done any benchmarks, or do you have any theories about how large these patches might be and how many of them might be used or in active use?
Let's see, I can do that type of calculation fairly quickly. So I don't need this stuff off the side anymore from all my size calculations from before. So given our current, so you're talking 49 by 49 times our 2 bits per. So if we assume an average of, let's say, 40% compression, that's just, a number. You're looking at just under 2K per patch.
And then if you, how many patches would you,
Actually, let me redo that, because if you think about it, most patches aren't going to have every single vertice modified.
I hear what you're saying, Lee, but I've watched you playing around with the sculpt tool, and the first darn thing you do is zoom way out, and you're actually editing 5 or 6 at a time.
Right.
That means every point is being modified. I'm just pointing that out.
Well, that was just because for visual representation, that's much more effective. But okay, even if we say 40%, so 2K.
Now you were going to ask what, Nelson? How large are the patches, or
no? How many patches would you think? Let's say, how? Just to give a general idea, like what, like a mile, 2 miles squared?
That's what I meant by how large. Yeah, how big are the patches across?
Oh, they're
how many patches are we?
Well, yeah, but if you start out with what the size is across in meters or even in relationship to miles, then from there we can start kind of trying to.
Isn't it 49 by 49 square
that
meters?
Many.
What is that?
And then times that by 2.
I don't know what he's doing.
It's a big number. What unit is that?
That would be the amount of information needed to save if every single vertex in a 512 by 512 array of patches of 140. Well, that's 144 meters. There's 49 vertices per patch across. So and then for the experimental non-repeating world that I've been playing with, there's 512 patches across. That gives us just over 2,000 square miles of terrain. So there's that, and we square it. So this is the number of vertices in the entire, in 2,000 square miles of terrain. And if there's 2 bytes per, worst case scenario, uncompressed, if everything was changed, there would need this much information.
You say uncompressed? That's based off the 2K. That is compressed, isn't it?
No, that's no RLE whatsoever.
Oh, okay.
Uncompressed. So if you look at dividing that by a meg, that works out to...
What, 1.2 gigs?
Yeah, about 1.2 gigs total. For 2,000... Really... actually, it's 2,100 square miles.
It's not sounding like it's going to be an issue to keep a majority of this in memory. Or if keeping it all in memory and just persisting to a database, just like we were planning on doing with the game data anyway. Because that's not really big. 1 gig for, what was that, 2,100 square miles or whatever?
Yeah.
By the time we get enough players to populate 2,100 square miles, I think we would have the money to buy another terabyte hard drive in the server. Or terabyte of memory on the server.
If you also implement a dynamic load and unload, so you're only loading in the patches that people are, or the surrounding patches that people are actually in, you could knock that down significantly.
Sure, but worst case scenario, it's still not terrible.
Right.
No, it's not terrible.
See, my idea was to store each individual patch as a file in a file system, given its identity, which would probably be its offset. But that's only what, like 24K? Did you say that was? Like
what's that?
An individual patch. If everything was changed.
Oh, each patch, if everything was changed, is 49 squared times 2. So right around 4K.
4K. That's not very big.
Yeah, that's each patch uncompressed. Everything changed.
See, here's my idea, because we haven't even talked about this yet, but I remember someone did say something about versioning the changes to the terrain.
Mm-hmm. Yeah, that was me.
It would be interesting if we stored each individual patch as a file on a file system to use a source control system like Git to actually version each individual patch. I don't know. It's just an idea that pops into my head when you guys were talking.
Well, the reason I brought that up is because Jason and I had discussions about the possibility of allowing people to own land. Jason really, really likes that idea. And me being, opposed to giving them unfettered access to change things. If there was a review process and the ability to look at what they've done to the land first and then approve or deny it or roll it back if needed, would be very, very cool.
But anyway, besides that, as far as storing it, I think that really probably the most efficient way I see in my mind is as changes come in, write them to the file system, and then on application boot, just load every single patch into memory, and then stream that out as needed. And then if it ever does become an issue where we're loading in over, 500 megabytes worth of data, doing what Lee just suggested with just loading in data that people are actively using would fix that. Mm-hmm. I mean, what do you guys think as far as that mechanism for persistence?
This really comes down to a discussion between the two of you at this point. I'm just listening in case I have any concerns.
Well, my main concern is coming up with a way of prefetching the information, because getting the information from the server is going to be a bottleneck if I try to do it on a row-by-row basis as needed. So probably at some sort of zone load or going from some area to another, we make a request to the server that at some point I'm going to need the information for X number of patches. And then it starts sending me that information as fast as it can. And then I pre-cache it, and then I've got that saved in memory on the client side. and then that goes out. But we also need a mechanism for instant changes. So that would be prefetching stuff. But if I'm painting stuff, there needs to be a mechanism that needs to get sent to you so you can get that information, get it modified in your memory, and send it off to anybody else that may be in the world sculpting at the same time so they can see it.
I guess probably the easiest way to do that would to be on the server side, keep a list, keep some sort of data structure that relates each individual patch to each individual person that's interested in that patch. And then whenever a change comes for that patch, it just redistributes it out. And then as you move forward and backward through the world, your client then tells the server to subscribe or unsubscribe himself from a particular patch.
Right.
I mean, that sounds like it makes sense to me. I mean,
No, I don't see a problem with that because with the system as it is, there's a very specific visual area of the world. I've not implemented a cached version of the world. So every patch that is in the world is visible at any given point in time. So I initially planned when we got to this stage and we started messing with it, I'd have a larger non-visible representation of the world in memory that held all this information. And that's where we could implement the subscribe, unsubscribe. So anything that's visual inside of that player's world is something that they would definitely be interested in. They could subscribe to those patches and get updates via it. And anytime they change it, those updates can be sent to you, and then you can redistribute that to everybody who may be interested in that area.
What do you mean by you redistributed? Are you talking about peer-to-peer?
No, you as in the server.
Okay.
So the client part should only be listening or getting changes from the server, and then anytime that client makes a change, that needs to get submitted to the server. Server needs to update that information and then send it off to whoever may be interested.
So as far as the client's concerned, the only thing you need to really create is some sort of method that can be invoked, RPC'd or whatever. I don't know how Photon works at all.
Well, no, I what I'd like to see for the first step is simply going to be just client side. Pretend there is no server. Let's just do a proof of concept with just this as a standing application by itself.
You mean as far as just encode it, write it out, and then read it back in?
Yep.
I've already got the code to do that, so that's not hard. I did that with one of my other projects that I did. So I have the ability to take a patch, take its information, turn it into a memory stream, encrypt it, or not encode it, compress it, and then write it out to a file, read it back, and put it back. So those methods already exist.
You could probably do one step further by actually implementing the structure of what it would be as far as the client's concerned.
Yep.
Oh yeah, it would be. It would be the 2-bit or the 2-byte structure.
Well, I mean, as far as like create some sort of like interest management. I mean, you could create an interest management thing without talking to the server at all, and then just create like a method stub that, like I said, because does Photon, is that all RPC? Does Photon like tell a client to invoke a particular method on the client, or does it
sends messages?
Okay, so in that case, you would just write a. Oh yeah, you said those messages had a cap, a size cap on it.
Yeah, it's a little over 1K each, but it automatically will handle files larger and reassemble them. So
you're talking about just before the fragmentation takes place, which is actually a little bit larger than that. But I don't want to get into Photon at the moment.
What I mean is you could also probably even stub out a method that that just receives the terrain data that's invoked by some other sneaky thread sitting on your client that just loads it from the file and sends it off to that method.
Mm-hmm.
And then at that point, it would be the entire functionality that the client needs minus the server part.
Mm-hmm.
Right.
So you said you have code. Is the code that you're talking about that you already have, Lee, in your current code, or?
It's in my code base. It's not inside this project. It's what I wrote for the other project I'm working on.
Okay.
So it is hand-rolled code. It's not relying on any other frameworks.
Okay. All right, well, let's do this. We're at 15 minutes now. Let me go ahead and bring this discussion to a close, and then we'll do a quick discussion on where we want to go from here as far as starting to design or play with things. The only reason I'm saying that people don't realize is it's, what is it, 4 in the morning, 5 in the morning? What time you got, Lee? Yeah,
4:30.
All right, so give us just a minute, and we may be back. Thanks a lot.